Hello and welcome back to another lecture. In this lecture, we will create the Nat Gateways using Terraform Modules. To create the Nat Gateways, the first thing I want you to do is open your project folder. Once you open your project folder, the next thing we will do is create a folder for the Nat Gateways in the Modules directory. To create a folder for the Nat Gateways, I want you to select the Modules directory. Once you select the Modules directory, I want you to right-click on it. Not the VPC, the Modules directory, right-click on it and select New Folder. Give the folder a name, call it Nat Gateway. Once you've given the folder a name, press Enter. There you go. We have created the folder for the Nat Gateway in the Modules directory. This is the folder we will use to store our Nat Gateway module. Next, we will create two files in the Nat Gateway folder. So I want you to right-click on the Nat Gateway folder and select New File. Give the file a name and call this first file main.tf. Once you've given the file a name, press Enter. Next, we will create the second file. Right-click on the Nat Gateway folder again and select New File. Give the file a name and we will call this file variables.tf. Once you've given the file a name, press Enter. We have created two files in the Nat Gateway directory. The first file is the main.tf and the second file is the variables.tf. You can see both files here. The next thing I want you to do is select and hold this variable file and drag it somewhere here. Once you drag it here, you will split the screen. On the right side, you have the variables file. On the left side, you have the main.tf file. Another thing you can do to create space is close the Explorer by clicking this button here. The next thing I want you to do is download and open the reference file for this project in this video's description. This is the reference file we will use to create the Nat Gateway, and in this reference file, I've included all the resource type and arguments we need. The next thing I want you to do is select everything in this reference file. I'll press Ctrl A to select everything. Then right-click and copy it. Once you copy it, close the reference file. Then in your main.tf file, paste it in there. Once you've pasted it, scroll all the way up. I'm going to drag this to the right to create more space. To create our Nat Gateway, first we have to allocate an elastic IP, and the first syntax will allow us to allocate an elastic IP. This is the resource type to allocate an elastic IP, and this is the reference name I've given it. The first argument is the VPC. For this, we will type true. The second argument is the tags. We'll give it a tag name and we'll call it Nat Gateway AZ1 EIP. We are going to create two Nat Gateways, one in the first availability zone and the other in the second availability zone. So we need to allocate two elastic IP address, and the second syntax will allow us to allocate our second elastic IP. This is the resource type to allocate an elastic IP, and this is the reference name I've given it. For any of this syntax, if you want to find it in the Terraform documentation, all you have to do is copy this, paste it in Google, and it will take you to the exact location of this syntax in the Terraform documentation. Just like we did up here, the first argument is VPC. For the VPC, we will type true. The next argument is tags, and for the tag name, we'll call it Nat Gateway AZ2 EIP. The next syntax will create the NAT gateway in the public subnet AZ1. This is the resource type to create a NAT gateway, and this is the reference name I've given it. The first argument is allocation ID, and this is how we allocate our elastic IP to the NAT gateway. Remember, we created our elastic IP here. We will select the resource type and the reference name, copy it, then come back down. We will paste it here. Remove the double quotes, add a period, come all the way to the end, add another period, and type ID. The next argument is subnet ID, and this is the subnet we want to create the NAT gateway in. We want to create the NAT gateway in the public subnet AZ1. So we need to reference the public subnet AZ1 from our VPC module. Remember, in the last lecture, our subnet is in our VPC module, and we export some values in the output file. If you look in the output file in the VPC module, we export some values here. One of the values we export is the public subnet AZ1 ID. That is the value we are going to reference here. To reference the public subnet AZ1 value that we export in the VPC module, we will use the same exact name we used to export it. So I'm going to copy this. Then come to your main.tf file. To reference it in here, we'll type var dot and paste the name you copied in there. This is how you reference the public subnet AZ1 from your VPC module. To reference any value in another module, first you have to export those values. In our output file in the VPC, we export these values, and we can now reference these values in any other module. We have to use variable to reference those values, so don't forget to put the variables in your variable file. So in here, we will type variable and give your variable a name. The name of your variable will be public subnet AZ1 ID. Then I'm going to bring this back up and have something like this. The next argument we will enter here is the tags, and we'll give it a tag name. We'll call it NAT Gateway AZ1. The next argument we have here is depend on. According to the Terraform documentation, the NAT gateway needs to depend on the internet gateway. So in here, in brackets, we are going to reference our internet gateway. Remember, we export our internet gateway from the VPC module. If we go to the output file in the VPC module, and I'll scroll all the way down, we export the value for our internet gateway here. I'm going to copy it. Once you copy it, come back to your main.tf file. In your main.tf file, we are going to use variable to reference it. So in here, we will type var dot and the name of the internet gateway we copied in the output file. So I'm going to paste it there. This is how we reference the internet gateway we created in the VPC module. Remember, we are using variable to reference the value of our internet gateway. And don't forget to put that variable in your variables file. So in here, I'm going to copy this and paste it down here. Then modify the name of the variable. The name of the variable is internet gateway. I'm going to copy this and paste it here. This is all we need to do to reference the value of our internet gateway. The next syntax will create another NAT gateway in the public subnet AZ2. This is the resource type to create a NAT gateway, and this is the reference name I've given it. The first argument is allocation ID, and this is the elastic IP we want to allocate for this NAT gateway. Remember, we create the elastic IP up here. It is the elastic IP we call NAT gateway AZ2 EIP. So what I want you to do is copy the resource type and the reference name. Then come back down, paste it here, remove the double quotes between them, add a period, come all the way to the end, add another period, and type ID. The next argument is the subnet ID, and this is the subnet we want to create this NAT gateway in. Remember, we created our subnet in the VPC module, and we export the value of the subnet in the output file. So click on the output file. We will create our NAT gateway in the public subnet AZ2. So in this output file, let's look for where we export the value of our public subnet AZ2. This is where we export the value of our public subnet AZ2. So what you are going to do is select it and copy the name. Once you copy the name, come to your main.tf file, and under subnet ID, we will type var dot and paste that name in there. This is how we reference the public subnet AZ2 ID from the VPC module. The next thing we will do is create that variable here. So what I want you to do is copy this and come down here, paste it there. We are going to modify the name. The name of the variable is public subnet AZ2 ID. Copy this and paste it here. The next argument is tags. For the tag name, we will call it NAT Gateway AZ2. For the next argument depends on, this NAT gateway also needs to depend on the internet gateway. Just like we did up here, we will copy this and paste it here. This will allow the NAT gateway to depend on the internet gateway we created in the VPC module. The next resource will create a route table that we call private route table AZ1. And we will use this route table to route traffic through the NAT gateway in the public subnet AZ1. This is the resource type to create a route table, and this is the reference name I've given it. The first argument is VPC ID, and we created our VPC in the VPC module. So to reference the VPC ID, we have export the value in our outputs file in the VPC module. Select the outputs file. In the outputs file, I'm going to look for the value where I export the VPC ID. I'll scroll up. This is the syntax that we use to export the value of our VPC ID. So copy the name. Once you copy the name, come back to your main.tf file. In here, just like we did for the rest, we will type var dot and paste the name there. This is how we reference the value of our VPC ID that we created in the VPC module. The next thing we will do is enter the variable here. So we'll copy this and paste it down here. Then modify the name. You want to change the name to VPC ID. I'll copy the VPC ID again and I'll paste it here. The next argument we have here is route. And for the route, the first option is CIDR block. This is going to route traffic anywhere on the internet. And the CIDR block to route traffic anywhere on the internet is 0.0.0.0/0. We'll type that in here in double quotes. The next option is the NAT Gateway ID. And this is the NAT gateway we are using to route traffic to the internet. For this syntax, we want to route traffic through our NAT gateway in the public subnet AZ1. You can see it here in the comments. So here, let's go up to the syntax where we created our NAT gateway in the public subnet AZ1. This is the syntax where we created the NAT gateway in the public subnet AZ1. So copy the resource type and the reference name. Once you copy it, come back down and paste it here. Remove the double quotes, add a period, come all the way to the end, add another period and type ID. The next argument is tags. We'll give it a tag name and we'll call it private route table AZ1. The next syntax will allow us to associate the private app subnet AZ1 with the route table we just created. This is the resource type to associate a route table with a subnet, and this is the reference name I've given it. The first argument is subnet ID. For the subnet ID, this is going to be our private app subnet AZ1. Remember, we export the value of our private app subnet AZ1 from the VPC module. So go to the output file in the VPC module. In the output file, let's look for the value where we export our private app subnet AZ1. This is it here. So what I want you to do is copy the name, private app subnet AZ1 ID. Copy it. Then come back to your main.tf file. In here, we are going to reference it by typing var dot and paste that name there. The next thing we will do is create the variable in our variables file. I'm going to copy this. Then I'll press enter and I'll paste it in there. Then we will modify the name. Copy the name again here and paste it here. The next argument is our route table ID. We created our route table up here, so we'll copy the resource type and the reference name. Once you copy it, paste it here. Remove the double quotes between them. Add a period. Come all the way to the end. Add another period and type ID. To create space here, I'm going to drag this in a little bit so you can see everything better. The next syntax will associate the private data subnet AZ1 with the private route table AZ1 we created up here. This is the resource type to associate a route table with a subnet, and this is the reference name I've given it. The first argument is subnet ID. The subnet we want to associate with this route table is private data subnet AZ1. Remember that subnet is in our VPC module, so we'll go to the output file in the VPC module. In the output file, let's look for the syntax we use to export the value of our private data subnet AZ1. Down here, this is how we export the value of our private data subnet AZ1. The name is private data subnet AZ1 ID. So copy it. After you've copied it, come back to your main.tf file. To reference it in here, we will type var dot and paste the name there. Once you paste the name, don't forget to enter the variable here. We'll copy this and press enter. Paste it down here. The next thing we will do is modify the name. The name is private data subnet AZ1. Copy it again from here and replace this with it. The next argument is the route table ID. We created the route table up here, so we are going to copy the resource type and the reference name. Then come back down here, paste it there. Remove the double quotes. Add a period. Then come all the way to the end, add another period and type ID. We will use the next syntax to create another route table that we will use to route traffic through the Nat Gateway in the second availability zone. This is the resource type to create a route table, and this is the reference name I've given it. The first argument is the VPC ID. We reference the VPC ID up here. So we don't need to copy it from here anymore. We can just copy it from here. Then come back down, paste it here. The next argument is route, and the first option for the route is CIDR block. The CIDR block to route traffic to anywhere on the internet is 0.0.0.0/0. So we will type it in here in double quotes. Once you type the CIDR block, the next option is the Nat Gateway ID. Remember, we created our Nat Gateway in the public subnet AZ2 up here. This is the syntax we use to create our Nat Gateway in the public subnet AZ2. So copy the resource type and the reference name. Once you copy it, come back down and paste it in here. Remove the double quotes, type a period, come all the way to the end, type another period and type ID. The next argument is tags. We'll give it a tag name and we will call it private route table AZ2. We will use the next syntax to associate the private app subnet AZ2 with the private route table AZ2 we just created. This is the resource type to associate a route table with a subnet, and this is the reference name I've given it. The first argument is subnet ID, and this is the ID of the subnet we want to associate with this route table. The subnet we want to associate with this route table is the private app subnet AZ2. Remember, we export the ID of our private app subnet AZ2 in the VPC module. So select the output file in the VPC module. In here, we export the ID of our private app subnet AZ2 here. So copy this name. Then come back to your main.tf file and paste it in here. Before you paste it, we will type var dot and paste the name. This is all we need to do to reference the ID of our private app subnet AZ2 that is in our VPC module. The next thing we will do is also create the variable here. So I'm going to copy this variable and press enter, then paste it here. The next thing we need to do is just modify the name. So I'll copy this name again and replace this with the name. The next argument is the route table ID, and this is the route table we want to associate this subnet with. Remember, we created our route table up here. It is the private route table AZ2. So we will copy the resource type and the reference name, then paste it here. Remove the double quotes, add a period, come all the way to the end, add another period and type ID. We will use the last syntax to associate the private data subnet AZ2 with the private route table AZ2. This is the resource type to associate a subnet with the route table, and this is the reference name I've given it. The first argument is the subnet ID, and this is the ID of our private data subnet AZ2. Remember, we export the ID of our private data subnet AZ2 in the VPC module. So select the output file. This is the syntax we use to export the value of our private data subnet AZ2 ID. So copy it. Then come back to your main.tf file. In here, we will reference it by typing var dot and paste that name in there. Once you paste the name, don't forget to create the variable here. I'm going to copy this, press enter, and paste it down here. Then I'll modify the name by copying the name down here. I'll copy the name and replace this value with the name. This is how we reference the value of our private data subnet AZ2 that we created in the VPC module. The last argument we will enter here is the route table ID. Remember, we referenced the route table ID up here, so we can copy it and paste it here. This is all we need to do to create the module for the Nat Gateway. Make sure you review your syntax and ensure that you have typed everything correctly. The next thing I want you to do is save your file. I'll select File and select Save All. Once you've saved your file, close the output.tf file and the main.tf file. The next thing we will do is use the module we just created to create our Nat Gateway. To use this module to create your Nat Gateway, let's go in our Jupyter website ECS folder. Select it. In that folder, select your main.tf file. This is the main.tf file that we are using to create our resources. So what I want you to do is come down here, type your note here, call it create Nat Gateway. Once you have typed your notes, the next thing we will do is write the syntax to reference our Nat Gateway module. To write the syntax, press enter, type module. Once you type module and press enter, the first thing we will do is give our module a name. Call the module name Nat Gateway. Once you've given your module a name, then come down here. On the first line, the first argument we will enter is source. So type source in here. Once you type source, add a space, enter the equal sign and another space. The source argument is how we tell Terraform the location of the module we want to reference. Just like we did up here, we are going to type double quotes and 2 period. The 2 dots is telling Terraform go up 2 directories. This means that we will come out of the Jupyter website directory and we will go into the modules directory. So the next thing we will type here is / and type the name of the modules directory. We called it modules. So type modules in here. Make sure you type it exactly how you spelled it here. Once you type the name of the directory, enter another /. Then the next thing you will enter is the name of the module you want to reference. The name of the module we want to reference is Nat Gateway. So we will type the name in here, Nat Gateway. Make sure you type the name exactly how you spelled it here. Once you've specified the path to the module you want to reference, the next thing we will do is enter our arguments down here. So what I want you to do is select the variables file in the Nat Gateway module. Select the variables file we just created. Then what I want you to do is take this variable file, drag it here, and drop it here. So you have the split screen again. I'm going to close the Explorer for now to create more space. And I'll drag this here. These are the variables we just created in the Nat Gateway module. So all we need to do is reference this variable as arguments down here. To reference them, I'm going to press enter and I'm just going to copy the name of these variables one by one and arrange them here. When you copy the name, add a space, press the equal and add another space. Then copy all the name and arrange them here the same way. Once you've copied all your variables name and enter them here, the next thing I like to do is clean up my code. For the equal sign, I always make sure they are aligned under each other. So what I will do is press the tab key here. Then once you type it here, you can align the rest of the equal sign under this equal sign. To align the equal sign under each other, all I did was press the tab key. Once you've aligned your equal sign, the first value we will enter is the value for the public subnet AZ1 ID. Remember, the public subnet AZ1 was created in the VPC module. So to reference the ID of the public subnet AZ1, all we have to do is in here, we will type the module that the subnet was created in. The subnet was created in the VPC module. So here we'll reference it like this: module dot, the module stands for this module. Then the next thing is you will enter dot, the name of the module. The name of the module is VPC. So we will type VPC here. And you will add another period. And the value we want to reference is the public subnet AZ1 ID from this VPC module. So we'll just copy this and paste it here. This is all we need to do to reference the value of the public subnet AZ1 from the VPC module. The next thing we will do is enter the value of the internet gateway. Just like we did here, we will do the same thing. First, we will type module, period, then the name of the module where the internet gateway was created. The internet gateway was created in the VPC module, and the name we gave that module is VPC. So we will type VPC in here. Once you type VPC, enter another period, and the value we want to reference is internet gateway. So copy internet gateway here and paste it here. To explain what we are doing here, open the Explorer file. Remember, in the VPC module, we export some values. These are the values we export. The exact name we use to export them are the same exact name we are referencing here. That is the same name we also add to our variables file. The first time I started using Terraform module, it was a bit confusing, but the more you start creating resources using Terraform module, everything will be clear. You must learn how to use Terraform module because most of the code you will be working with at work use Terraform module. The next argument we will enter is the value of the public subnet AZ2 ID. Remember, we created the public subnet AZ2 ID in the VPC module. So just like we did here, we will start by typing module, then period. The name of the module we want to reference is VPC, period. And all we have to do is copy this value and paste it here. If you look at what we are doing so far, you'll see the logic. The next argument we will enter is our VPC ID. Remember, our VPC ID is in the VPC module. So here we will start by referencing the module. Type module. Once you type module, type period. Then the name of the module is VPC. We'll type VPC. Another period. And all you have to do is copy this and paste it here. The next argument we will enter is the private app subnet AZ1 ID. The private app subnet AZ1 ID is in the VPC module. So to reference it, we are going to type module, period. The name of the module is VPC. We'll type VPC. Another period, and we'll just copy this value and paste it here. The next argument we will enter is private data subnet AZ1 ID. The private data subnet AZ1 ID is in the VPC module. So we'll start by typing module, period. The name of the module, VPC, period. And we will copy this value and paste it here. The next argument we will enter is the private app subnet AZ2 ID. The private app subnet AZ2 ID is in the VPC module. When we create the VPC and we created our subnets, that is when the ID will be generated. So that is why we are referencing those values in the VPC module. To reference the private app subnet AZ2 ID, we will start by referencing the module. Type module dot. The name of the module is VPC. Type VPC. Another period. and copy this, then paste it here. The last argument is private data subnet AZ2 ID. Just like we did for the rest, the value of the private data subnet AZ2 ID is created in the VPC module. So we will reference it by typing module, period. The name of the module is VPC. We'll type VPC, period, and we'll copy this and paste it here. And there you go, we are done. This is how you write the syntax to create a NAT gateway using Terraform module. The next thing I want you to do is save your file. I'll select File. I'm going to select Save All. Once you've saved your file, I'm going to close the variable.tf file. We don't need it anymore. And I'm also going to close the outputs.tf file. We don't need it anymore. The next thing we will do is create the NAT gateways in our AWS environment. To create the NAT gateways, I want you to select your project file. So make sure you select your Jupyter's website ECS folder. Whatever name you give your project folder, make sure you select it. I'm going to right click on it and I'm going to select Open in Integrated Terminal. When you select your project folder and select Open in Integrated Terminal, what it will do is it will open the terminal to the directory of your project folder. This is very important. So once you've opened the terminal to the directory of your project folder, the first thing we will do is type Terraform init to initialize. Once you type Terraform init, press enter. There you go, we have successfully initialized with AWS. Once you have initialized with your AWS environment, to create the NAT gateways, we will type Terraform apply. Once you type Terraform apply, press enter. When you type Terraform apply and press enter, the first thing it is going to do is show you the plan. Here Terraform is telling me it will create 10 resources in my AWS environment, and to see the resources you can scroll up here to see all the resources that Terraform will create. Once you have reviewed the resources, you can scroll back down. And here Terraform is asking you, do you want to perform these actions? We will type yes and press enter. Terraform is now creating the NAT gateways in my AWS environment. We will give it some time to finish creating it. There you go, Terraform has finished creating the NAT gateways in our AWS account, and it took 2 minutes and 4 seconds to create them. Let's go to the management console to verify that the NAT gateways are there. In the management console, type VPC in the search box and select VPC under services. On your VPC dashboard, on the left side, select NAT gateways. Here you'll see that we have 2 NAT gateways. The first one is NAT gateway AZ1. The second one is NAT gateway AZ2. If you select the NAT gateway, you'll see more information about it. For this NAT gateway, this is the elastic IP that was allocated to it. And for the second NAT gateway, you can see the elastic IP that was allocated to it. The second NAT gateway is in the public subnet AZ2, and the first NAT gateway is in the public subnet AZ1. Everything looks fine, and these NAT gateways are in the Jupyter VPC. If I select the second one, it is also in the Jupyter VPC. Another thing we can review are the route tables. Select route tables. To see just the resources in your VPC, under filter by VPC, select this drop down and select your Jupyter VPC or whatever name you gave it. These are the route tables in my VPC. I'm going to drag this out. You can see my private route table AZ1 2 subnets are associated with it. If you select the private route table name, we'll select routes, and I'll drag this up. You can see this route table is routing traffic to the internet through the NAT gateway. If we right click on this to open it in a new tab, this is the NAT gateway AZ1. I'm going to close it. Under subnet associations, 2 subnets are associated with this route table. Everything looks fine. Let's review the private route table AZ2. I'll select it. We'll review the routes. It is routing traffic to the internet through this NAT gateway. I'll right click to see what this NAT gateway is. This is the NAT gateway in the public subnet AZ2. I'm going to close it. Then I'll select subnets associations. 2 subnets are associated with this route table. It is the private app subnet AZ2 and private data subnet AZ2. After reviewing these resources, everything looks fine. Let's go back to our Terraform file. In the Terraform file, the next thing we need to do is push our code to the GitHub repository. To push your code to the GitHub repository, select source control here. And the first thing we will do is type a message. I'll type created NAT gateways. Once you type your message, click this check mark to commit it. And once you've committed your message, click sync changes to push it to your GitHub repository. I'll click this button. And there you go. We have successfully pushed our NAT gateway module we just created to the GitHub repository. Let's go to our GitHub repository to verify that it is there. In your GitHub account, click the home page. Once you select the home page, the next thing we will do is select our repository. Our repository is Terraform Modules. We'll select it. In this repository, select the Modules folder. And there you go. In the Modules folder, you can see the NAT gateway modules we just created. If you select it, in it, you can see your main.tf file and variables.tf file. This is how we use Terraform module to create NAT gateways. If you have any questions or there's any part of this lecture you don't understand, please leave your comments below. Thank you, and I'll see you in the next lecture. Bye.